All right, so in this video, I'm going to cover the phase amplitude form in section 4.9, mechanical vibration. Um, so phase amplitude form, we haven't seen this one in 4.9. Um, the the undamped and damped free mass spring vibrations. So once we figured out the general solution, the form of general solution of the mass spring system, and then we try to simplify the general solution, we get the one single sine function form. That form is called the phase amplitude form. What that means, um, 1 second. So let me see from there. Give me a second. So for example, when you consider the undamped and the free mass spring system, okay, in this case, the governing equation going to be my dou prime t, right, plus k times y of t is equal to 0, right? So we got this y, the ox equation going to be m times, and then the r squared plus k times r is equal to 0. M r squared plus k equals 0. So r going to be, excuse me, so r going to be what? The square root negative k over m, right? K over m. Okay, so this is equal to square root k over m and then I. Now, square root k over m, we say that the omega is called the natural frequency, right? Omega was natural. Right. So now, in here, so and then the general solution form y of t was what? That was the C1 times e to the alpha t, and then cosine omega t plus C2 times e to the alpha t, and then sine omega t, right? And since the alpha, which alpha is what? The real part of the complex root in Ox equation, which is 0. So this is 1. This is 1. Okay, so we got C1 times cosine omega t plus C2 times sine omega t, right? Okay, so now then what? Then we express this one as like this: it's a times what the sine, right? Okay, and then omega t, and then plus phase angle pi, right? Okay, so how come? Okay, how can you get this expression from here? And then yeah, I'm gonna cover this one in detail. Okay, so so now give me a second. Let me see. First, we're gonna start from the right triangle. Okay, this is a pi, right? And this is a. Okay, this is b. Okay, here since this notation, I mean, is complete with that notation, let me change the amplitude a to just r. Okay, r. Okay, so just for convenience, because I'm not gonna I don't want you to be confused with that letter and that letter. So now then r gonna be, therefore r gonna be the square root of a squared. Okay, square root of a squared plus b squared. Right? Okay, right. Then now then cosine r. Okay, then cosine pi is going to be a over r, right? Remember that? Cosine a over r, okay, and then sine, and then tangent, right? Okay, so cosine pi is a over r, and then tangent pi is b over a, and then sine pi gonna be b over r, right? Okay, keep in mind this. Now also, I'm gonna use the first one. The second one, I'm gonna use the trigonometric identity. Cosine x minus y is equal to cosine x, the cosine y plus sine x, the sine y. Okay. Then now using these two, oh, can you see that? Okay, using these two the formulas. So I'll try to express this one as like this. Okay, and then that expression is called the phase amplitude form. Okay, phase amplitude form. So all right. So now let's see C1. Give me a second. Okay. So now I'm gonna replace the C1 and C2 with A and B. Okay. So this is gonna be A. This is gonna be B. Okay. Sorry, just make confused. Okay. So now then A times cosine omega t plus B times sine omega t, that is equal to. All right. So you see that here, we could express A in terms of trigonometric function from here. Cosine pi is A or R. It means the A is what? R times cosine pi. Okay. And then cosine omega t. Right. And then plus, also B is equal to what? R times sine pi, right? R times sine pi. And then sine omega t. Let's see. Okay. Now we're gonna, by using that trigonometric identity, this is equal to what? R times cosine omega t minus pi. Okay. So, and that is equal to R times um, the what? Cosine. Second. So we got the yeah. So we're gonna get the R times cosine, right? And then omega t, and then minus phase angle pi. Okay, but yeah, you make it. Yeah, so here the phase amplitude form is, you can see the R times sine omega t plus t, right? This one is also that is also called the a phase amplitude form. Okay, but how can you get this sine instead of cosine? Yeah, we just applied other trigonometric identity, then we're gonna get the sine function, not cosine, instead of cosine function. I'll show you. So in here, we're gonna use the sine x plus y. We're gonna use that trigonometric identity. Sine x plus y gonna be sine x, and then cosine y, okay, plus cosine x, and then sine y, okay. And then in the right triangle, we said this is b, and then this is a, and this is phase angle pi, okay. The r is square root, and the a squared plus b squared still, right? Okay. Then the y of t was what? The a times, I mean in this case b times. I mean you see here, we replace C1 with A, right? That was a C1, and then we replace C2 with B. This is C2. Now this is C1, and this is C2. Okay, all right. Just keep in mind this. And then general solution was the what? C1 times cosine omega t plus C2 times sine omega t, right? And this is equal to same as b times cosine omega t plus a times sine omega t. Right? So this is equal to what? B is what? So here we can express b in terms of sine, which is r times sine pi. Give me a second. Yeah, so the b, it was what? R times sine pi, right? Pi, and then cosine omega t plus was a. A was what? A is the r times cosine pi. A is r times cosine pi. Okay, sine omega t. Right. Now the applying this formula into here, then you're gonna get r times sine omega t plus p sine pi. Okay. So now either r times sine omega t plus pi or r times cosine omega t minus pi are called the phase and amplitude forms. Now next one, excuse me. So the okay, so r is what? Actually, r is square root of c1 squared plus c2 squared, right? And then, but what about the phase angle? Okay, so let's figure out the phase, how to find out phase angle pi, especially the sine of pi. Okay, a range of not range of the pi. Okay, so mm, excuse me. So we got this. A is what? R times. So give me a second. Let me use that y of t. Okay, let me see is equal to r times cosine omega t minus pi. Let me use that phase amplitude form. Okay, so now then that was a, right? This is b and this is r, right? Okay, and then a was the r times cosine pi, and then b was the r times sine pi, right? Okay, so now I'm gonna uh, use the polar coordinate system. Okay, so this is x and then y. Okay, then for example, this is pi, and then this is point a comma b is right there. There's a comma b. Okay, and then the what? A is this one, right? Then b is this. Okay, then the a comma b, the that coordinate system, that coordinate, Cartesian coordinate system is equal to what? R comma pi. R is what? This is R, right? You know, on a polar coordinate system. Okay, so now let's see if C1 is greater than, I mean, keep in mind this is C1, okay? This is C2. C1 is greater than 0, and the C2 is less than 0, which is the fourth quadrant, right? Okay, and then well, we can say that pi is equal to 2 pi plus the alpha. Here alpha is between negative pi over 2 and 0. This makes sense. What that means, okay, this is x-axis, here y-axis. And then C1 is greater than 0, C2 is less than 0, so maybe A is right here, B is right here. Okay, okay. Then the alpha going to be 2 pi plus negative, I mean, it's kind of 2 pi minus some radian, right? Okay, so we express that one as like the 2 pi plus pi. Okay, so that is actually, oh, oops, that's going to be pi, phase angle pi. Okay, then this is alpha. Okay, and then what happened? Then what? Tangent alpha is equal to, see the tangent alpha is what? Tangent alpha going to be what? B over A, which is C2 over C1, right? This is A, oh, yeah, right? Okay, you see? This is B, okay? Which is, this is a C1, this is a C2, okay? Right? So tangent alpha going to be what? B, right? Over A, okay? So now let me see. B over A. So then alpha is going to be what? Arctangent B over A. Okay. Thus, the phase angle pi is going to be 2 pi plus arctangent B over A. Okay. That's why if C1 is positive and C2 is positive, C1 is positive. Oh, give me a second. This here. Give me a second. C1. So yeah, this is a C1. Okay, so give me a second. It's confused, right? So this is B, right? This is A. I'm sorry. Okay, so this is C1 is B and this C2 is A. I'm sorry. Okay, that's why the give me a second. C2, C1. Yeah, that's why C1 is greater than 0, C2 is less than 0. So C2 is less than C1, B. Yeah, this is the what? Actually, I'm sorry. This should be C1, right? This should be C2. I'm sorry. So C2 is what? Since it's B, that's the B, right? Okay. And the C1, this is A. I'm sorry. Okay. So that's why the C1 is positive, C2 is negative, which is the A comma B is in the fourth quadrant. Then arctangent, then the what? Phase angle pi in the fourth quadrant. Okay. And then this is how to find out phase angle pi. Okay. Now, next one. What if A is less than 0? Okay. And then B is also less than 0. Okay. So it means that C1 is less than 0 and then C2 is less than 0. Okay. Then arctangent, I mean, what that means? It means that what? This one, A comma B is in the third quadrant, right? Okay, x-axis, y-axis is A comma B. Okay, this is R. So that's the phase angle pi, right? So here's a B. So C2 is less than 0. So this is B right here, okay? And then C, oh, I'm sorry. Give me a second. C2 less than 0. So this is the what? Give me a second. Yeah, this is B, right? C2 is less than 0. And then C1 is less than 0. This is A. Okay. Then tangent alpha going to be a tangent alpha. I mean, the pi can be expressed as a pi plus alpha, and then alpha is between 0 and pi over 2, right? So tangent, then alpha, I'm sorry, the alpha is equal to what? B over A, right? Okay, B over A. So pi is equal to arctangent and B over A, right? So now then, alpha, I'm sorry. Okay, so then pi is equal to pi plus arctangent B over A. Okay. So now next one. So what if the A is less than 0? I'm sorry. Give me a second. C1. Yeah, C1 is less than 0. It means the A is less than 0. Okay. And then C2 is positive, which means B is greater than 0. So C1 is less than 0. It means that C2 is greater than 0. And then AB is right there. Okay. So that's the pi, right? So here is a B. I mean, oh, this is the what? A, right? C1, which is A. Okay. So now this is the right here. This is C2, which is B. Okay. Then Bayesian pi can be expressed as pi plus alpha. Here, alpha must be what? Negative pi over 2, 0, negative pi over 2 and 0. So alpha is greater than negative pi over 2 and then less than 0. Okay. Okay. So this is going to be alpha. All right. So now then what? The pi can be expressed as pi plus arctangent what? B over A. Right. Oh, let me see. The next one, if A is less than A is 0. Yes. What if not A is 0, but what if A is greater than 0 and then B is greater than 0? It means that C1 is greater than 0 and then C2 is greater than 0. Okay. Then A comma B is right there. Okay. So that's going to be just pi, right? All right. So pi is going to be just what? Arctangent of what? B over A, right? Okay. So here is the here's A. This is B. Okay. So arctangent is going to be B over A. Okay. So, and then that's why you see we got that the formula. Okay. C1 in the first quadrant, Bayesian of pi is between 0 and pi over 2. Okay. And then this one, pi is equal between the pi over 2 to pi. Okay. And then if C1 is C1 and C2, okay. In third quadrant, pi must be what? Pi 2, 3 pi over 2. And then here, pi is 3 pi over 2 to 2 pi. Okay. That's why we got this one. So now, so let me stop here. Okay. So now, next time, next video, I'm gonna cover the 4.10. Okay. So damped and then damped, undamped, and then the mass spring system with the non-zero external force term. Okay.